All right, so the next 2 pages are going to be really important for us. I would have to say it's probably 2 of the most important pages because if you get these ideas confused, it can really mess your answers up. In other words, we're going to be talking about independent events and then mutually exclusive events. And on one of them, you're going to be multiplying probabilities, and the other one, you're going to be adding. So I think you understand if you get those 2 switched, it can go horribly wrong for you. All right, so pay attention. Independent events. Events A and B are independent events if the probability of event B occurring is the same whether or not event A occurs. All right, so example, are these events independent? You flip a coin twice. You get heads on the first flip. All right, what is the probability that you get tails on the second? It's still 1 out of 2. It doesn't matter what you flipped on the first coin. The probability for getting tails on the second coin remains the same whether or not you did anything before then. So yes, they are independent. You draw a card from a deck and draw a second card without replacing the first. That is not independent, and the reason is this. When you don't put that card back, it's going to change the probability for the second one because it's not out of 52 anymore, is it? Probability is now out of 51. And if you're drawing the same suit or something like that, there would be fewer of that kind left as well. So the probability would change. So no, not independent. If events A and B are independent, the probability of both A and B occurring, well, first of all, look at this, A and B, okay, is the probability of A times the probability of B. Okay, the problem sometimes with these is that the and is implied. Sometimes you might not see the word and, so you actually have to think about the problem, okay? Doesn't mean an and. So when the word and does appear, beyond a shadow of a doubt, you know that you will need to multiply. It indicates multiplication. So I'm sorry, you are going to have to think on these. All right, example 8. 2 cards are drawn from a deck. What is the probability that both cards are red, assuming the cards are drawn with replacement? Well, as you see here, there's no and anywhere. So we're saying that we're looking for the probability that you drew a red. And I'm being a little bit wordy here, and then another red. So you're looking for a red and a red, okay? So they didn't say that, did they? But when both cards are red, that's exactly what's happening. So we need probability of a red card times the probability of a red card. I think I'm going to wish that I had not written so big. So the probability of drawing a red card is 26 out of 52. If you put the card back, the probability of drawing another red card is 26 out of 52. I have to scooch down here. That gives me 676 over 2,704. And some of us have calculators that will figure this out to be 1/4 without all the preliminary calculations. All right, B. 2 cards are drawn from a deck. What is the probability the first card is a heart and the second is a face card, assuming the cards are drawn with replacement? So without being as wordy this time, we're assuming that one is a heart and Then the other one is a face card. Okay. So there are 13 hearts. Okay. And there are 12 face cards. So again, we're putting the card back. Okay, so multiplying across, that gives me 156 out of 2,704, which will reduce to 3 out of 52. Okay, a bag contains 10 ping pong balls numbered 0 through 9. So that's going to be, again, 10 ping pong balls. Ping pong balls. If you draw 3 ping pong balls at random, what's the probability that the first is greater than 6? Okay, and then the second is odd. And then the third is divisible by 3. The balls are replaced after each draw. Okay, so greater than 6, that's 7, 8, 9, so that's 3 favorable out of 10 total, and odd, so that's 1, 3, 5, 7, 9, that's 5 favorable outcomes out of 10. Okay, and then is divisible by 3. So 0 is divisible by 3. Oops. 3 and 6 and 9 are all divisible by 3. So times 4 out of 10. So that gives us 60 over 1,000. Reducing informally here. Dividing by 10 gives me 6 over 100. Dividing by 2 gives me 3 over 50. Okay, so next we have you roll 4 dice. What's the probability you do not roll any numbers less than 3? So we're looking for the probability of rolling greater than or equal to 3 and greater than or equal to 3 and greater than or equal to 3 and one more time greater than or equal to 3. So what numbers are greater than or equal to 3? Well, that would be 3, 4, 5, and 6. Okay, so that's going to be 4 out of 6. 4 out of 6 times 4 out of 6 times 4 out of 6. Okay, you could write that as 4 out of 6 to the 4th power, right? Either way, that will give us 256 over 1,296, and that reduces to 16 over 81.